Hello everyone! Very nice to be with you watching second part of the video through science lenses. In the first part we discuss what is science, its presuppositions, its specific narrowed scope, being physical and experimental, and mentioned few terms which science relies on: rationality, truth, objectivity and realism. Let's move on to the next level and discuss a little bit scientific features, criteria, principles. First feature. Science is one of the liberal arts. Remember we discussed term objectivity and mentioned that science is public and shared. If scientists can learn something, so do you. And what makes science, which is liberal art, actually liberal? In a brief, science is not for limited group of people, not for scientists only. It's open for everyone, not only to learn but also to question. Probably you know there is a mechanism of internal audit in lots of fields, as well as in a scientific world. It's named as peer review process. Scientists examine each other's scientific work either to confirm or disprove certain outcome. It's kind of internal method of checks and balances. But you, even if not being a scientist, also can question and challenge scientific outcome. So science as a liberal art welcomes such external audit as a legitimate action. Being liberal means to be open to new opinions. Just few comments not to go deep. External audit, let me quote, must neither underestimate nor overestimate science asset and liabilities. And scientists also have the right to respectfully question competency and accuracy of such external audits. Please also note that science has a common sense underneath. So when anyone wants to question science, please be sure that there is no questioning of common sense along with scientific outcome. There is no need to question that moon exists or that all objects are falling down. Only valid non-scientific questioning worth scientific world to spend time on investigation. That was about feature of science being a liberal art. Next scientific criteria tells us about importance of evidence. The basic elements which work for science are evidence and observation. And any scientific theory must satisfy and follow the observed data. If theory explains or predicts something, but observation gives different data, such theory must be questioned as being in a trouble. If someone thinks that moon has yellowish color and its craters look like dots on a Swiss cheese, then he or she may come to a conclusion or theory that moon is made of Swiss cheese. It may be even supported by some jokes from NASA with funny pictures of moon's cheese expiration date. But what can you do with real NASA's Apollo program when astronauts from different expeditions between 1969 and 1972 made several moon landings, stepped on a moon surface, and confirmed that it made of rocks and not from a cheese? We have real observations coming from several people and supported by photographs taken and online TV translation. Neil Armstrong, Edwin Aldrin, Charles Conrad, Alan Bean and 8 other astronauts landed on our moon during Apollo space travel program. So what do we need to do with such a cheese-assumed theory? Of course we need to throw it away. So remember, data underdetermine theory, no matter how well one theory explains a set of observations. It is possible that another theory may fit just as well or even better. Let me wrap up. Evidence and observations are very, very important for science. We will discuss next the principle of parsimony by William of Ockham, often called Occam's razor. Sometimes also called the principle of simplicity or the principle of economy. It advises scientists to prefer the simplest theory among those that fit the data equally well. If few explanations are all in agreement with the evidence, then Occam's razor votes for the simpler explanation. Historically, two different but related things can be touched when discussing parsimony. First is about nature, which goes the simplest ways. So parsimony is a feature of nature. And the second one is about choosing the simplest theory, explanation, which supports the same evidence. In other words, parsimony is a feature of good theories. For example, mountain rivers water in nature tries to find the shortest way to come down from the mountain top to the bottom. If there would be a cliff, water would not try to find a bypass. There will be a waterfall. Whatever brings water down faster and simpler way. All naturally spherical or round shapes are very optimum for lots of things around us, from big cosmic bodies like our sun or planets around, to small rainwater drops. Gravity and some other simple mechanisms bring bodies in such shapes. It's about parsimony as feature of nature. But we are more interested in parsimony as feature of good scientific theories. Long time ago there was a geocentric astronomy model explaining that our universe has Earth in its center. Such model is dated back to ancient times of Aristotle and Ptolemy, around 2000 years back. They had instruments, telescopes, to extend our human vision to decent distances. And there were very precise calculations made about planets' paths, also named orbits, within our solar system. There were formulas to calculate any known planet position at any time. But imagine how inconvenient to calculate position of Mercury or Venus planets, for example. There are several parameters involved to mathematically explain orbits. Other planets' orbits have different patterns if compared with Mercury's or Venus ones within the geocentric model. Then it was Nicolaus Copernicus, around 500 years back, whose revolutionary new heliocentric model offered Sun in the center of our solar system instead of the Earth. His planet's orbit calculations were as well accurate as they were before with the geocentric model. But choosing model by Copernicus was actually based on parsimony principle. His heliocentric model was simpler and involves fewer parameters. And various planets' orbits were presented in a harmonious and simple system for all planets in our solar system, not only for Mercury and Venus. That is about principle of parsimony in choosing theory. Next scientific criteria is criteria of falsifiability, which was given by Karl Popper. Not everything from Karl Popper is accepted by scientific world, but his criteria that theory can be scientific only in case it can be falsifiable is well known and useful. So criterion of falsifiability allows to separate science from non-science. What does it mean, falsifiability? Just to clarify, Popper did not think about how true is the theory itself. He was concentrated on criteria to make a statement: is theory scientific or non-scientific? Please note that theory can be scientific, and in the meantime eventually it may be proved to be wrong. So falsifiability of anything, including theory, statement, model or anything else, means in short a feature to be verified as being possibly wrong. There should be a way to verify theory, if talking about theory. Such falsifiability criteria intersects a lot with previously discussed importance of evidence and observation, which can help to support validation of a theory. It intersects even with historical narrowed-down scope of scientific thinking. Science is considered as a physical and experimental science to the exclusion of theological and metaphysical. Do you remember discuss it earlier in the video part 1? Again, evidence and observations are very, very important. In case you could see a group of people discussing some secret which cannot be verified by themselves and anyone else using evidence and observation, even though some parts or complete discussion's outcome might be truthful, and everything might sound logically strong, these people are far away from scientific way of thinking. I am not trying to make assessments, I'm just talking the same way as Karl Popper, that such discussions are non-scientific. Again, it's not about discussion being not truthful, wrong, good or bad. It's just about discussion being non-scientific. So we just mentioned few things regarding scientific features and criteria. Liberal arts, importance of evidence and observation, principle of parsimony and criteria of falsifiability. One more thing. Let's talk about risks and limits of scientific thinking. Just about few of them. But don't be prejudiced, actually non-risks could potentially help to overcome some of them. Anyway, we need to look from outside with balanced way of thinking, not blindly put scientific way above or below other ways of thinking, but logically assessing advantages and in contrary risks or limits. First item. When we talk about science, we keep in mind human science, and human way of thinking has some issues. It just happened evolutionary. And scientists are also humans first of all, which consequently may bring issues into scientific way of thinking. Scientists, as well as we are, may be informed about logical and cognitive issues, but sometimes even such prior knowledge cannot save them from all issues with our human way of thinking. Maybe you've already heard about terms logical fallacy and cognitive bias. Fallacy is an error in reasoning, which may lead people to false conclusions. And cognitive bias is a systematic pattern or deviation from norm or rationality in judgment. We'll see a couple of examples in a moment. There are very famous types of logical fallacies and biases, which were even given names. For example, the confirmation bias. What is it about? First, it's about our brains pushing us to search or interpret information and observation in line with our own subjective, currently existing beliefs. And second, it's about our brains pushing us to interpret in a different way or even ignore data which is in contrary to our current beliefs. Scientific approach, in contrary, should welcome at the same time all relevant data to equally potentially support as well as potentially disprove preliminary idea about anything. But our human memory plays a trick and tries to find and notice things for us that would match with information we already believe. It's like instead of all relevant data given by web search engine, our brain works as an advertising company paid lots of money to put most or even all results to be in favor to only advertised existing beliefs in our brains. Just to give a couple of examples regarding confirmation bias. If you believe that living nowadays is very dangerous everywhere because of gun violence, you would probably ask your web search engine with the questions like, how dangerous is gun violence? Or how many incidents due to gun use? But if in contrary you don't believe that it's very dangerous everywhere, your searches most probably would be like, where is the most dangerous place because of guns? Gun violence in my community, in my town? I'm not giving here my opinion about gun use. What I'm trying to say here only that your questions might be constructed to predetermine answers, to confirm your beliefs, instead of trying to collect more different type of evidence and come probably to a different conclusion. I'd like to quote from Gabriel Principer book, see reference at the end of the video. When both men and women were asked to read a study to claim that caffeine was risky for women, women who were heavy caffeine drinkers tended to doubt the study. My comment about it: imagine that scientists who conducted such study are all women who drink a lot of coffee every day. In order to even start a study or obtain objective scientific information, such scientists need to be aware where possible and need to be above confirmation bias in their heads. That was about bias. Let me also give an example of logical fallacy here. They also have specific names and related explanations. One of them named poisoning the well. Simplified, the fallacy goal is to present information about a target person with the intention of harm good reputation and everything that the target person says. To me, it's a shift in focus from discussing a topic to personal bad traits, which leads for others and probably for you to an assumption that it's better not to trust such a bad person in general. I had very good lesson in my life. When I had a telecom project, we discussed some equipment and software bugs with a competitor to present joint report to a customer. Both technical engineer and his project manager on a competitor's side were trying to hide obvious technical bugs from being mentioned in our report. And they used tactic to drag my focus from the main topics to irrelevant ones to achieve that hiding bugs goal. It happened more than 10 times in a row, so I started not to trust them technically, making a conclusion that they are behaving badly and I should not expect any technically relevant and proper discussions from them in the future at all. What a huge mistake of mine. Because of poisoning the well fallacy played a trick with me. When on the 20th time they sent very technically relevant question discussing a bug with my equipment, I ignored it, because of my expectations with a zero trust for them at that time. I was pointed out to that question by my colleague almost at the very end of my project, having kind of zero time to analyze an issue deep enough. To oversimplify, if some person lies a lot, that does not mean that person is all the time liar. We always can expect truth from his mouth. If person is bad, it does not mean that he all the time will share only bad things with you. So it's just a couple of examples of confirmation bias and poisoning the well logical fallacy. You can read yourself about lots of other biases: authority bias, projection bias, incomplete comparison bias, and many others, as well as many logical fallacies. Imagine that scientists as a human may not get rid of such fallacies and biases at their scientific work. This is a room for incomplete scientific information and possible road to wrong outcome. Wrapping up. Science is not implemented as a robotic artificial method of gathering facts and all the time calmly without prejudice make an objective outcome, but through subjective human lenses, which has a room for possible mistakes. That was about first item about limits of science. Let's move to the second one. Do you remember we discussed science presuppositions in the previous video part 1? These presuppositions must be true for science goals to be meaningful and scientific methods to be rational. For example, if the physical world does not exist, or if we humans cannot perceive this world through our senses, then science would be destroyed. Unfortunately, science is completely not capable to prove presuppositions. Consequently, another limitation of science is that it cannot provide its own foundation. Please note that I am not arguing here against science. We discussed my point of view earlier as the opposite one. Presuppositions mentioned now only is just existing limitations for science. Let's move on to the third limitation of science. There is no absolute knowledge. Science will never observe, know, and explain everything about the physical world. This is a limitation. Each answer tends to raise 10 new questions. But an increase in precise and productive questions might be the greatest evidence of scientific progress. Here we finished first block of videos about science through science lenses. Let's check what we've discussed so far. We discussed starting point for scientific thinking, which consists of presuppositions and two main presuppositions about existing of physical world and our generally reliable human perception senses. To support such presuppositions, which can be proven, we used physical reality check disclosure. Remember, moving cars are hazardous to pedestrians. It helps to clarify to yourself which side you would like to choose, to agree with presuppositions or not. Hope you are on the side to support two main presuppositions. Then we moved forward and mentioned that science is considered as physical and experimental science, historically set in 1860s. After that, we discussed terms rationality, truth, objectivity, and realism. They are all the basis for scientific thinking. In the current video, the second part, we discussed scientific features, criteria, and principles. Do you remember discussion about science being a liberal art, importance of evidence and observation in science, principle of parsimony, often called Occam's razor, falsifiability criteria by Karl Popper? The last topic which we have discussed at the end was about some risks and limits of scientific thinking. We pay attention to logical fallacies and cognitive biases, natural to human and scientists as well. We talk about science unable to prove its own foundation, two main presuppositions. We mentioned that science will never explain everything about physical world. It's always on a discovery road. Now we have basic terms and understanding to continue our discussion about science and scientific thinking in the second group of videos named Methods of Science. Hope to see you there.